Hi guys, in this video we're going to be looking at a fairly cool chemical reaction involving sugar and bicarbonate of soda. Now the reaction itself does involve some burning. We're going to be providing the energy for this reaction by burning ethanol on a burning tray. Now in order to do this safely, in an ideal world you'd like a fire blanket nearby and a fire extinguisher nearby as well. Just in the worst case scenario, just in preparation for the worst case scenario. You should also have a heat-proof mat to do the reaction on. So, the reaction itself involves sugar and bicarbonate of soda in a 4:1 ratio. So I'm going to measure this out here. I'm going to do 40 grams of sugar, which we're nearly there, 38, 39, usually end up going over in the end. 41, what do you know, it has gone over. Typical. Close enough in any case. So 41 grams of sugar, and we're going for another 10 of bicarbonate of soda. This is the really exciting bit. 46, 47, 49, 50. Let's make sure we get our full 10 in there since we went over with the, that's it there. Okay. So, 4:1 ratio, and we want that fairly well mixed up there. Now, all that's going to happen is we're basically going to burn this. But we're going to burn it on a sand tray on top of a heat-proof mat. So first of all, what I'm going to do, I'm going to put on eye protection for this. I'm going to saturate the sand in this tray with ethanol. And like I said, that's going to produce, that's going to give us the fuel to burn. And we want it to be quite wet. Now remember, you can extinguish this at any point, so you don't have to be going overboard, making yourself uncomfortable with it. But this is just fuel for the reaction. And what we want is to create a depression in the middle of this, in which we're going to put our chemicals. So that should be plenty there. I'm just going to pop that into the middle here. It should be perfect. I'm going to saturate it with just a little more ethanol to be sure, because I've often done this reaction and it's not worked as well as I would like. So a little bit more fuel won't hurt. Now, it's important to remember that if at any point you feel uncomfortable with this chemical reaction, you can simply extinguish it by putting another ceramic mat on top of your reaction, and that's going to put it out. Now, the reaction itself is started quite simply. I'm going to remove anything flammable just with a spark, and it starts right away there. Now already we can see from this that the sugar and the bicarbonate of soda there is starting to blacken a little bit, and that's what we're looking for. So in terms of actual learning here, what's going on? Well, you can tick any outcomes to do with chemical reaction, so to do with chemicals combining to produce a new substance. And what we've got here is these two chemicals combining. Some of it's being released as a gas, but the rest of it is being turned into carbon dioxide. Some of it's being released as carbon dioxide, the rest of it is being turned into pure carbon, and that's the black substance that we're seeing here. Furthermore, we've got the production of light and heat from the fire itself here. But what I like to think of is, how can we make this a real experiment? At the moment, this is just a demonstration. And it's a cool demonstration for sure, but it is just a demonstration. How do we make it an actual, an actual experiment? Well, what you could do is you could try varying different things. So the essence of experiment is comparison. So as long as you're making a comparison, then you're doing an experiment. So we could try comparing, does it work better with bicarbonate of soda, or does it work better with baking soda? We could try comparing, does it work best with caster sugar, icing sugar, or granulated sugar? As long as you're varying different aspects of the experiment, then you're actually doing an actual experiment and not just a procedure. So the kids will find a demonstration like this interesting, but there's more instructive value if you actually try varying different things. So we've got this column of carbon being produced now, which is really quite cool, and the kids are always dead excited by that. If we kept this reaction going, it would go for quite some time. However, if we decide that we want to extinguish it, it's really as simple as just taking another ceramic tray and just popping it over there. And that's the reaction done with. So no real stress, nothing to worry about. I'd let that cool off for a little bit, and there you have it. Oh, going a bit squint there. So, in and of itself, it's a pretty nice demonstration. Pretty cool, good fun to do. But in order to make it more valid in terms of an experiment, you want to be thinking about what variables you can change. And you can put that to the class and set it up in situ. So, do you want to try it with caster sugar versus regular sugar? Do you want to try comparing baking soda? Do you want to try a different fuel? As long as you're comparing something and changing only one variable at a time, that makes it a real experiment. And that's what we want to be getting kids thinking about. We want to get them thinking, right, how do I turn something from just a cool thing we did in class that day to actually getting us thinking like a scientist? How do we actually make it the scientific method? So yeah, give it a shot. Not the kind of thing I'd get all the kids doing on all the tables. There's no way I'd be trying that in a primary classroom. But you as the teacher can demo it and then get them to suggest variables that we could interfere with. Give it a wee shot. Cheers.